So welcome back everybody to your fifth chemistry lesson. Today's focus will be on Bohr models. So I'm going to start off with a reminder from yesterday on electron shells. So the regions surrounding the nucleus, which is shown in yellow in the image to the right, are called shells. So the first shell can hold up to 2 electrons. The second shell holds up to 8 electrons. The third shell holds another 8 electrons. And then the fourth shell can hold up to 18 electrons. Elements with similar properties have similar electron arrangements. So I'm going to go into trends on the second next slide, but just drawing your attention to the right-hand image. So you can see that the nucleus is surrounded by a shell which can hold 2 electrons, and then the next one can hold 8 electrons, the next after that can hold another 8, and the next one after that can hold 18 electrons. In order to move to the next shell, the shell closer to the nucleus, so the one before, must always be full. So the shell with 2 electrons must be full before you can fill the next shell, which can contain up to 8 more electrons. So another review of just understanding the information from the periodic table. For today's lesson, you're going to be using the periodic table a lot, so it's important that you understand how to read it. So again, our modern periodic table includes the following information. The 22 in the corner represents the atomic number. The element symbol, Ti, is for titanium. The element name, titanium. The atomic mass is 47.9 for titanium. And the ion charges, in this case, because it is multivalent, is 4 plus and 3 plus. Remember that the atomic number is always unique to each element. It will never change. It's always going to be 22 for titanium. 21 is a totally different element, as is 23. So for all elements, the number of protons is always equal to the atomic number. The number of electrons is equal to the number of protons, which is equal to the atomic number. Again, this is specifically for element atoms. The number of neutrons is equal to the mass number minus the atomic number. And this is because the nucleus is made up of protons and neutrons only. And this encompasses the majority of the mass of an element, as electrons essentially weigh nothing. It's such a tiny amount, it's not actually counted. So a review again from yesterday's lesson. This is scandium, which is element number 21. So that means it has an atomic number of 21, 21 protons. The neutrons is equal to the atomic mass rounded. So 45 minus the 21 protons, which is equal to 24. Electrons is equal to 21 because we're dealing with an atom. It has a charge of +3. Plus meaning it has given up or it has lost 3 electrons. Therefore, in the ion, it has 21 electrons. So it gives up the electrons to become more stable. Basically, it wants to get rid of the extra 3 electrons in its valence shell, allowing it to become a more stable element in its ion form. So I would like you to just pause here and check your work from yesterday. Make sure you have filled in the table correctly and make sure you make corrections if you have any mistakes. I'm just going to walk you through calcium, which is the first example. So you were provided with an atomic number of 20, which is always the number of protons. So you can fill that in with 20. Using the atomic number, that means it's element number 20, which if you look at the periodic table is calcium. And then so its symbol is Ca. We can calculate the number of neutrons based on taking the atomic mass, which I believe in this case was 40, subtracted by 20, giving us 20 neutrons. The number of electrons in the atom is also 20, in this case because we're dealing with an atom. On the periodic table, you were told that it has a charge of 20, which is a property you will notice in all of the alkaline earth metals. This means that it has lost 2 electrons, bringing the ion number of electrons down to 18. So again, just pause here, make sure you have correctly filled in. For the multivalent ions, such as mercury and iron, I have given you both ion charges, and calculated electrons gained or lost based on that. So you should be able to calculate it regardless of which ion you are presented with. A quick review of standard notation. So standard atomic notation is a shorthand way scientists use to communicate important information about the atom or ion of each element. In this case, I'm just focusing on the atom. So write down the symbol for potassium is K, write the mass number above and to the left, 39, and the atomic number 19 to the left of the symbol. Sorry, the 19 got erased here, so I'm just going to quickly fill in the 9 so you don't get confused. So this should be 19. So again, this is a review from before, but as mentioned previously, elements in the same chemical family, so moving up and down the periodic table, so vertically, have the same number of valence electrons. So if I'm looking at the first family, which is the alkali metals, starting with lithium and sodium, these all have a valence shell with 1 electron in it. Moving over to the alkaline earth metals, which is number 2, you'll notice that each of the 2 shells shown, so beryllium and magnesium, both have 2 valence electrons. And then if you're looking at group 13, boron and aluminum have 3 valence electrons. Family 14, carbon and silicon, have 4 valence electrons. Nitrogen and phosphorus have 5. Oxygen and sulfur have 6. And then we get into our halogens. So fluorine and chlorine have 7, so an almost full valence shell, making them very, very reactive because they want to gain 1 more electron. So these all have 7. And then your noble gases, which is helium, neon, and argon, all have 8 electrons in their valence shell, meaning they're very stable, they're happy being stable, they're not going to want to gain or lose electrons. So let's apply what you've learned, and this is also technically review from yesterday, but it's good practice. So somewhere on your notes or a separate sheet of paper, you should follow along with this. So helium, which on our periodic table is He. If you look at the periodic table, it has a total of 2 protons. Because we're dealing with the atom, it has 2 electrons. And then its neutrons, we figure out based off of the atomic mass of 4 minus the atomic number 2, leaving us with 2 neutrons. So, and I've left a note at the bottom, remember the shells are filled in a 2-8-8-18 pattern. So we start off by drawing our nucleus and make sure it's big enough that you can provide your information inside. On today's worksheet, because you're limited on space, worst case, you can write the element and then write the proton number and neutron number just off to the side. But that information should always be included when possible in the nucleus. So I'm going to make a note here that this is helium. Protons we symbolize by P+. Yesterday I just represented it with P, but P+ is a better representation. We write the number in front, so it's 2P+. And then we write the neutrons, which also make up the nucleus, is 2N, and then this little circle means not. It just means 0 because it has no charge. From here, we're going to draw our first shell. Sorry, my circles are awful. This shell can hold 2 electrons, and helium only has 2. So in this case, I'm going to draw 2. Different teachers will teach you how to place the electrons in a different way. I was always told to separate them at first, going around. So in one at the top, one at the bottom, one to the right, one to the left, and then you would pair them up after that. If you space them out evenly, that's also fine, but either try to separate them evenly or pair them up in groups of 2, never more than 2. So this is the finished Bohr model for helium. So let's move into our next example, which is carbon. So carbon is symbolized by C. If we look on the periodic table, it has 6 protons. That's its atomic number. It's an atom, so it has 6 electrons. And then our neutrons, atomic mass is 12 minus the atomic number of 6, leaving us with 6 neutrons. So again, I'm going to start off by drawing the central nucleus. Symbol is a capital C. We have 6p plus for 6 protons, 6n naught for 6 neutrons. First ring can hold 2. So that is 2 out of 6 electrons used. We have 4 left to go in our next shell. So I have 1, 2, 3, 4. So, and then if you were to go back and count these over again, 1, 2, 3, 4, 5, 6 total electrons. So it should always add up to the total number of electrons that you have. Don't actually draw those X's. That was just me marking it so you could see what I was doing. Okay, so that is the completed Bohr model for carbon. So now you are going to try this out. So I have made an assignment which includes it's basically like a mini periodic table with just 20 elements. You'll see that it has some little boxes included and things like that. You're going to lay this out just like you would the periodic table. So in the top left corner, actually here I'll draw a box here so you can kind of see what I'm talking about. The worksheet is spread across 2 pages because if you were in school, we would give you a giant piece of paper to work on one, but obviously you don't have access to that at home. So just print out the 2 sheets and work on it that way. So we've got, I think it gives you these instructions. Write the mass number in the upper left corner. So this would be mass. Write the atomic number in the bottom right corner. So atomic number, the symbol for the element goes in the bottom right corner. So say we were dealing with carbon, it would go in here. So the remainder of the space in the box here will just be used for the Bohr model itself. As you are limited on space, and because you've included the element symbol in the bottom right corner, the nucleus of this Bohr model only needs to include the number of protons and neutrons with your electrons surrounding it. Other than that, please use your periodic table to complete pages 91 and 93 in your notes. So there's no fill in the blanks, I don't think today. It's basically just practice questions, getting you working with, standard notation, and as well, I think there's a couple tables for you to fill in, just solving different questions. So yeah, just follow the schedule in terms of what to do next from here. And that is it for your lesson today.